You have 6 minutes to turn your computer on, go to the line, and answer the 5-question logic. Submit and go to the lab assignment. If you finish every, please go to the calendar again and open the worksheet, temperature, heat, and unit. Download that and go to the corner to the download plate. Double click and you're going to find a Word document. Save this Word document on your 50 file, Unit 7, and name it temperature, heat, and unit. Could you please go to the calendar again and go to submit day 1 keynote temperature definition. Once you are there, you need to go to attach and then attach the document and then submit that. After that, you need to go to the log report. It's 1 per group. And then you need to decide what person is going to submit that and do the same thing. Go to the log report, double click. You're going to see the attachment, attach your document, and submit that. You have 5 minutes in total to submit these two assignments. Once you are in deadline and finish your homework, go to the calendar again. If you cannot see all the calendar, all the document in the calendar, could you please go to more or calendar view? Make sure that you sign in, because some people, they don't sign in here and then they cannot see the whole documents on the calendar. But if it's the case that you cannot see that, just double click right here on the calendar view. Then now what happened is you are going to see this the full calendar. And then today is the 10th. That means you need to go, I told you to go to the temperature, heat, and its unit. Double click there, please, or just click there. And what happened is it's going to your download the document. And then don't wait, because you know you are not going to see the document. Just go to this little arrow right here, shows download, okay, this one, and then click there. And then right here, double click in your document, okay? And then what happened is, what you need to do is write your name, okay? I'm going to delete the extra space, okay? Please do it. And then now the date, okay? And today is 1/10/13. And then we need to change this one, is 13. And now you are going to be watching the video, and then you don't need to watch the video for this question. You need to answer first reading. What happened to the internal energy of the system when work is done on it? Remember what we did yesterday. Okay? What happened to the internal energy of the water, molecules of water and molecules of air when we add heat? Okay, and then you just need to answer that. Okay? Then I'm going to guess is okay? And then now you need to answer what happened to the temperature. Then if you add heat, and then you need to answer that question there. But please do this one. You need to save that file. Okay, could you please go to save us. And then if you have a, I have a, go to the desktop. Okay, I have a lot of folders right here, but I have a folder for the whole physics and for the second semester, and I have a folder for the unit 7. And then just what you need to do is call this one temperature, and temperature, heat, and its units. And then say that. Okay, please do it.
Your rebound. The story so far. When the degree of hotness or temperature of something goes up, its molecules go faster and it expands. This expansion can therefore be used to measure temperature itself. A device which does this is called a hotness meter or thermometer. On the Celsius scale thermometer, the level to which mercury contracts at the freezing point of water is labeled 0 degrees Celsius, and the level to which mercury expands at the boiling point of water is labeled 100 degrees Celsius. And now, temperature versus heat. Here's a bucket of hot water at 50 degrees Celsius. And here's a cup of freshly boiled water at 100 degrees Celsius. In which of these two containers are the water molecules moving faster? The bucket or the cup? That's right, because the degree of hotness of the water in the cup is much higher than the degree of hotness of the water in the bucket. And the hotter something is, the faster its molecules move. Would you say, therefore, that there's more hotness in the cup than in the bucket? In that case, if the water in your swimming pool is just a bit too cold for you, you'd be better off emptying the cup full of boiling water into it, rather than the bucket full of water at a lower temperature, wouldn't you? Or would you? You don't seem so sure. Let's do an experiment to find out. Suppose you had two identical swimming pools, one yellow and one blue. And suppose that the water in both of them was just a bit too cold for you. When you pour the cup of boiling water into the yellow pool, does the water feel any warmer? You can hardly feel any difference at all, can you? Now pour the bucket full of 50-degree water into the blue pool. How does that feel? Quite a bit warmer? Aha! So even though the water in the cup was considerably hotter than the water in the bucket, the 50-degree bucket water is much better at heating up swimming pools than the 100-degree cup water. Why is this? Well, let's look at the facts. The bucket obviously contains many, many more water molecules than the cup does. The temperature of the average molecule in the bucket is 50 degrees, and the temperature of the average molecule in the cup is 100 degrees. Now let's substitute something else for the molecules. Imagine that instead of molecules, the cup were filled with $100 bills, and the bucket with $50 bills. Which would you rather have? Each individual bill in the cup is worth much more than each individual bill in the bucket. But the total amount of money in the bucket is much greater than the total amount of money in the cup. It's the same with hotness. The degree of hotness, like the value of the dollar bills, is higher in the cup. But the quantity of hotness, like the quantity of dollar bills, is greater in the bucket. We know that it's the speed of the molecules that determines the degree of hotness of something. In fact, degree of hotness only depends on speed. It has nothing to do with how many molecules there are. Although the molecules in the bucket aren't going as fast as in the cup, there are more of them, so they more than make up in mass what they lack in speed. And it's mass, combined with speed, that determines quantity of hotness. We've already seen that the word for degree of hotness is temperature. Now it's time to introduce the other word for quantity of hotness, which is heat. The big difference between temperature and heat is that temperature depends on speed only, whereas heat depends on both mass and speed. The water in the cup has got a high temperature, but very little heat. And the water in the bucket has got a much lower temperature, but a great deal of heat. Now you know why buckets of 50-degree water are better at heating up swimming pools than cups of boiling water. On the other hand, if you're looking for somewhere to dump your tea bag,
Now, would you please, I'm going to give you 4 minutes to answer the first page in your worksheet. Make sure that you have saved your Word document. Now we are going to check if you have the right answer. Checking for understanding. What happens to the internal energy of a system when work is done on it? Increases. And then you know that the internal energy of a system increase, then what happens with the temperature? Okay, increasing the work is because we have changed the kinetic energy. That means increasing the kinetic energy, then the temperature is going to increase. Now after the video, okay, in which of those 2 containers are the molecules of the water moving faster? We know that that is going to be in the cup. Because the molecule has more kinetic energy, higher temperature. Molecules, I'm sorry. Heat means big mass of molecules that can transfer energy and big speed of the molecules of water. Okay, degrees of hotness. The speed of the molecule. Okay, temperature. Quantity of hotness. Big number of particles that can transfer energy. Big mass. And speed. Heat is the quantity of hotness. Degree of hotness is temperature. Okay, the speed of the degree of hotness is the temperature. The quantity, the amount is heat. High speed, high temperature. Small temperature, okay, but in the big bucket has higher capacity to transfer heat because you have more molecules. Okay, what is the difference between temperature and heat? The answer is temperature of a system depends just on the faster its motion of its molecules. The temperature depends on how the molecules are moving. If they are moving slow, low temperature. If they are moving fast, and then kinetic energy. Heat depends on the number of molecules. That means you have a lot of molecules, then that system has the capacity to have more heat. Now, right here is going to be temperature, capacity of transfer heat, high temperature, and then a capacity transfer heat. Why this one has a low temperature but has a big capacity? Because even though it's a big bucket, has a lot of water, has a lot of molecules, but they are moving slow because the temperature is 50 degrees. Okay, but has a big mass, has the capacity to transfer more heat. In the cup, the temperature 100 Celsius. That means the molecules are moving faster, but just few or a small amount of molecules, then the capacity to transfer heat is very low. What is the relationship between temperature of the substance and the speed of the molecule? You know that. Higher temperature of the substance transfer, the faster is the motion of the molecule. That means is a proportion direction. Increase in the speed, increase the kinetic energy, then increase the temperature. Define temperature, the degree of hotness, coldness of a body, but it's not just that one. Remember, we have another definition that is the correct, and is that average kinetic energy, okay, of the molecule. And could you please remember the definition and make that long definition that we were the first day. Okay, and it's right here. Okay, the definition of temperature is a measure of the average kinetic energy of the particle in a small sample matter, expressed in terms of units or degrees, designed on a standard scale. And then now that you have this one correct, save your document again and start working on the scale of temperature. Please keep on task. Remember, the grade depends on your work today and every day. Be ready to be tested at the end of the day. Thermometers and the 3 different units in the way we can measure temperature. But first, I want to make sure that you have a clear definition about temperature. Could you please go ahead and define temperature, the correct definition of temperature? I'm going to give you 4 minutes to do that. And it's going to be researching on Google. What you're looking for in Google? Explain how a common liquid thermometer works. You have 4 minutes to type that answer in this space. What we need to do is we need to analyze water. The lowest possible temperature is the absolute value. That is the lowest, that is the minimum. Okay. The lowest is negative 273.15 Celsius. That is a negative number. Remember, the water freezes. When it's snowing, the water, the ice is at 0. Okay, just know if that has more than 2 days, and now it's a very strong mass of ice, it's going to be low and it's going to be negative number. The lowest point that we can reach is negative 273.15 Celsius degrees. And, if you have if you want to convert it to Fahrenheit and you have 50 degrees, what you need to go do is use this formula. Okay, make a substitution of the TC, which is going to be 50 degrees Celsius, and then plug in the number and use a calculator to do that. To use a calculator, I recommend you, now that you have a computer, go to I'm going to show you what I did. Go to Google, and then just type online calculator. Just online calculator. One time Google is giving you the option, please go to the web to scientific calculator, and then you have this one. Now type the equation. You want Fahrenheit degrees. Then the equation is telling you parentheses 9 divide by 5, and now you need to multiply the Celsius degree, which are 50 Celsius, now plus 32. Okay, or you can use this number right here. Now enter, and you can see right here all the process, and then they're telling you that in 50 degrees Celsius, you have 122 Fahrenheit degrees. And then, okay, you can do this one with the rest. Another question, another equation that you have, okay, after you answer that is in the next, right here, for example, you want to use the formula T equal TC equal to TK minus 273 to convert to Kelvin. And then use just the formula, please, to do that. Please finish all